In this lesson, we're going to talk about legs IK with IKFK switch. So if you want to follow along, you can open C_05_roboriggy_start.blend. And you're basically presented with where we left off in the last lesson. To quickly recap what is an IK versus an FK, FK stands for forward kinematic, and it's all in the behavior of a chain of bone that has parent-child relationship. Now, to pose this legs, for example, you have to actually rotate each bones individually in order to get that pose. All right, so that's called, right there, forward kinematic. Now, there's two ways to get IK, or inverse kinematic behavior, so IK. And one way is to have the last bone of the chain and have that location not locked. And if you go under tool, you have auto IK. Now that allows to hit G and grab the last bone and pose the chain of bone from its last bone. And that behavior is called inverse kinematic. All right. Now the auto IK here is great for quickly posing a model. However, for animation, it's not the best, and I do not recommend using that. It's best to actually test quickly if the chain would work for an IK. But in terms of animation, it's best to actually create a proper chain of IK. And to do that, you simply select the last bone and you go to add the inverse kinematic constraint. And then from there, you don't need to specify a target or a pole target if you don't want to, but you need to set the chain length. Otherwise, it will move the entire rig, all right, as you can see. So I'm going to set the chain length to 3 in this case. And now I have the same behavior that I had with the actual auto IK tool here, except that I have it as a constraint and I can use that constraint in my favor, right? Now, the issue with not using a target and not using a pole target is that you lose a certain amount of control that you do have with an IK, all right? And also, by applying that directly on the FK chain of bone that is already there that define the forward kinematic, it's not a good idea to add the inverse kinematic directly on that. Instead, it's better to add that to a duplicated set of bones that will have that behavior. So you keep a greater control over it. And then from there, use a target as well as a pole target. All right. Now, before proceeding, I need to rectify an issue that I created by wrongly naming my bone. Now, the issue is not really an issue. It's rather that it's much easier to actually work if you can easily symmetrize on both sides. And because I forgot to put an underscore after the L or the R, I actually can't use the symmetrize tool. So to quickly rectify that, and first I'm actually going to make sure I log these location on that last bone. All right, so we'll have that locked back. We're going to quickly rename these. All right, so using Control F2, and then from there, make sure to select bones. And then in this case, I'm looking for LF underscore, and I want to have L underscore F underscore. And then press OK. So all 4 of these bones are now renamed, and I'm going to do the same thing on the other side. Now, the reason why I don't just do one side and symmetrize it after on the other side is because I've already created those vertex group. So because the vertex group are created, I need to rename them before so the vertex group also updates. Otherwise, when I'll try to symmetrize what is newly renamed and not the other side, it's not going to take the new names in consideration. So Control F2, and in this case, I'm looking for RF, and I want to switch it for RF. And then press OK. So I'll speed up that part a little bit because it's the same thing renaming the back one than the front one. You know, it's just Control F2 and rename the mistake for the new name. All right, so now that we have the new name, if you go ahead and select the robo and go take a look, you'll notice that now all the vertex group have the proper naming. So for working, we could technically delete one side and continue working that way. And whenever we're ready to symmetrize, it will actually take it in consideration. So to do that, tab into edit mode and simply delete these bones. All right, so I'm also going to select these bones and we're going to duplicate them. So press Shift D and I'm going to click on the right mouse so it snaps them back to where they were instead of moving them around. And then I'll press M and then choose a different layer. So these are going to become our IK bones. Now we also do not need those nice controls on there because they're not going to be visible. So we're going to go here with them selected. Also select one and then select all of them and simply press Alt and then click on that. And then we're going to get rid of those. Now, if you go back to the first layer, the FK bones still have. Now, we did not specify FK at the end because automatically any bones are forward kinematic bones. Now, this chain will become an IK chain. So for that, we can rename the .001 to a proper suffix. All right, so we're going to select all the bone, press Ctrl F2, and then we're going to rename these .001 to _IK. All right, and then press OK. So now we've got all 6 bone renamed to IK. Now we want to add the IK behavior to that, but instead of using the bone itself, we want to be able to use a other object, which is a target where it's going to end here. All right, so at the tip. So that way we have control exactly where the leg will meet the ground and something like that. So for that, let's select these 2 end of the bone and simply press E and then Z and then pull that down a little bit. And then we're going to go back to the pose mode and we're going to rename these bones. So this one is the left front leg _IKT for IK target. And this one is going to be the left B leg _IKT for IK target. Right? So now if I grab this, I can quickly go add a IK constraint, set it to 3, right, and add the armature, and then we're going to use the L_F_ leg IKT for IK target. So now if I grab that target and move it around, which I can't because it's a parent of this bone, so we need to make sure to unparent it. So tab into edit mode and press Alt-P, then choose clear parent, and then tab back out. Now, if you grab it, you can move it around like an IK. Now, the trouble that we have right now is the IK has no restriction whatsoever in rotation. So it doesn't follow the same behavior of the locks that we had earlier. So to rectify that, we need to lock it at an IK level. So if you select the bone and open the bone panel under inverse kinematic, you can lock some of the rotation. So in this case, I want Z to not be locked. I'm going to lock the other 2. And the same thing for this one, I want Z to not be locked. This one, we need all 3 axes. So we're going to do the same thing here. So we're going to lock these 2. And then we're going to lock these 2. So I can go ahead and quickly create the IK on this one, set it to armature, set it to a chain length of 3. Otherwise, it's going to move the entire rig, and you don't want that. So you just want it to affect these 3 bones. So you have to specify that. Then from there, we're looking for L_B_L for leg IKT, or right there. All right, so now if I grab this one and move it about, it's the same thing. All right. Now, when you pose a bone like that, it can cross like that. So you can set some limits as well. So if you go here, you see we have mins and max and so on and so forth. And everything that is not locked will show up like this. All right, so it's not grayed out, so it's not locked. So we can add a limit to that. And you can see we have a circle here that says the limit. Okay, where can it rotate and where can it not rotate? And right now it's set to rotate everywhere. So here, I don't want it to go past this. All right, so that guide is very, very nice here because it can help us say where we want this to rotate to. So this now shouldn't move past, but it still does. All right. So these rotate actually work, but we need to do it on the other bone too. So this one also needs that. So this bone should not be able to move past a certain point on the other side. So past that point, for example. So now if I grab this, it's going to stop there. It's perhaps a little too precise. So let's make it a tidbit further. Actually, I think I have the right one. So let's make it 8, for example. Yeah, it's still too much in. So let's actually increase it a little bit or decrease it to 7. There, let's try that. And then, okay, that's perfect. That's not exactly snapping on it. So it prevents it from going a certain point past that IK. Right? So this is one way to rectify that. I'm going to do the same thing on the other side. So I'm going to basically set up where we want this to move and where we don't want it to move. So we don't want it to be past that. And then this one is the same thing, except that we need the other one. So this one is going to be something like 7, or is it -7? -7 in this case, because it's the other way around. All right, so now I have those same sort of limits, so it doesn't sort of go through each other, all right, which would make sense for something like this. All right, so that's perfect. Now the problem that we have is that we can't really control the orientation of the legs, as you can see. All right, so we need to be able to do that as well. So in order to do that, we need to add what we call a pole vector. So if you grab these two, I'm going to go to this side view, enter edit mode. I'm going to select the end tip, and I'm going to press E and then Z, and I'm just going to bring that down. I'm going to make sure that I'm set to median point here, and I'm going to press S and then Y. So I'm going to scale that just like that. And then I'm going to press E and then Z again. So extrude that, and then scale and then Y. So it's pretty much straight with that. And I'm going to delete these bones. And I'm going to rename this one left leg underscore PV for pole vector. And I'm going to do the same thing with this one. Put underscore leg underscore PV. All right. So now we've got the pole vector. So now if I grab this, all right, I can specify here a pole vector. So if you choose armature, and in this case, we're going to look again for L underscore F underscore leg, and then we have PV. So now if I grab this, I can rotate the leg with that. So if I grab this and move it about, it's gonna flip when it reach where this is. So what you want is to a certain point, sort of automate it following this. To do that, you simply parent the pole vector to the control of the leg directly. All right, so if you grab this and parent it to that, so Control P, keep offset, that actually works very well as well. So you could pull that down and then move that way. And then all you have to do is to rotate this like that. All right, so it's the best way to automate it. All right, so let's do that on the other side. So I'm going to grab that and grab that bone. And then from there, I'm going to tab into edit mode, Control P, keep offset. So now both of these have a proper control to actually control the tilt of the IK as well as the IK. And it also has a pole vector that is semi-automated by the simple rotation of the IK. So this one, we need to specify the pole vector because it's not specified. Right? So I'm just going to do this real quick, and I'm going to grab these two, and I'm going to go Alt-G. All right, so now if I grab this and I specify the pole vector that I want, so it's going to be L underscore B underscore leg PV. Now this one is going to flip because it's sort of the invert of that one. And when we set the roll, it's on one side. So in this case, because it's the same roll, we need to go and put the pole angle to either -180 or 180, right? So now it follows that proper pole vector right here. So now if I grab this one and move it about, I can still have that control by simply rotating this. All right, so it's great for these type of legs. All right, but you still have that fine control over itself as well. All right, so it's great for that. So now we could mirror that on both sides or actually do the switch first. And I think that's what we're going to do first. For the forward kinematic to follow the inverse kinematic legs, we need to use a copy rotation constraint. So there's no easy way. You simply go and add the copy rotation constraint, select the armature, and use the same bone but in IK. All right, so left F and then arm. So L underscore F underscore A, and they should both show up. And then from there, you choose local space for both. And you need to do that for each of these bones where we need to follow that. All right. So L underscore F underscore, and that's the forearm. And then we can choose IK and local space and local space. And I will speed up this part a little bit because it's very repetitive. It's simply adding a rotation constraint, set the armature, set the matching bone in the IK, and set both of the source to be local space. And for the last bone, L_B, and that's the and FK. And the reason to put in local space is that since we're using a switch, it needs to have a local space on the bones. So now if I actually go and choose the IK, I can now actually move the legs, and it works with the rotation here to control the tilt. All right. So the way to actually turn that on and off is to use a driver. All right. So what you do is you add a custom property to this. Now, before doing that, let's quickly make sure that these bones are not set to deform. So select all the bone and press Alt and then click on the check for the form. All right. Or alternatively, you could select one and uncheck the deform and then select all these one and then shift select that one and right click on it and then copy to selected. All right. And now all these one will also be set to not deform. So another shortcut to do this. All right. So now they're set to not deform. Let's add a quick custom property. So at the bottom, you have custom property. If you hit add, you can actually go here and specify FK/IK because it's going to be forward kinematic to inverse kinematic. Set that to 0.0 and this to 0.0 and set OK. Now, if you expand the property, it shows up here when you have the bone selected and only that bone. So the switch is on the IK itself. All right, so I'm going to right click and copy the data path. Now, if I open this up, all right, so you can see it open, and we'll do the same thing for this one after. So if I open this up, and now I put the FK as well on, all right. So now if I go here, I can set a driver here. So we're gonna add a driver, and we're gonna set the variable to be plus 0.0, and then we're gonna switch that to a single property. We're gonna choose the armature, and we're going to paste that data path that we just copied. And if you update the bone, now the bone has snapped there because the switch will turn it on and off and anything in between. Now, what we can do for the rest is to simply actually copy this. So copy driver and go paste it there. So paste the driver there and paste that driver there. So now if I grab this and put it on and off, it actually puts the entire chain on and off. Now this bone on its own can move freely. All right, so you can dog that or whatever. All right, so now we've got a switch done on one. Let's create this switch for the other one. So we need to add that custom property. So let's go add a custom property, hit edit. We're gonna call that one FK/IK. And then we're gonna set them to 0.0, 0.0, and then press enter. And then we're gonna copy that data path. And then we're gonna select the bone here. Gonna right click, and then we're going to paste that driver, but we're going to edit it because we need to change that data path with the new one. So paste that in there, update the driver, and then copy that one. So copy driver, and then go paste it on the other one. So paste driver, click, and then right click, paste driver. So now I have a driver for the back leg as well. All right, so that's perfect. The limits we've previously set on the IK bones can sometimes cause issue when using the symmetrize function. This was rather to show you that it is indeed possible to limit IK bone rotations, but since we're about to use the symmetrize functions, which will flip the bones, it will also most likely have inverted limits, and that is why it's best to just remove them. So we can now go ahead and symmetrize this awesome IK/FK setup. So now to symmetrize this, we only need to select the bones that are within the chain that we need to symmetrize. So all these bones, and tab into edit mode and simply go to symmetrize. Now there's going to be two issues that is going to happen. It didn't properly copy the IK/FK switch constraint or drivers, if you will. The constraint themselves are fine. But in this case, it did not at all copy the data path here, nor this one. All right, so it basically just left them to the default value they were on. So we need to rectify that by simply making the driver here. So we're gonna add a driver, again, 0.0. And then from there, we're going to choose single property. We're going to select the armature and we're going to paste the data path here and update the dependency. And then from there, we can right click, copy the driver, and we're going to assign that driver to the other two. So paste driver. I'm going to do the same thing with this one. Paste driver. I can see that we have an issue with some of the vertex group. We're going to fix that in a bit. And then let's actually rectify the other one by copying the data path here. So copy data path. Let's put it to 1. The data path. Let's grab this one and let's actually paste the driver, right click, edit, and let's just quickly change that. Control V, enter, update dependency, right click, copy driver, and select the other two and paste the drivers in. So now we've got a proper IK-FK switch on both sides. Now only this one seems to have an issue with the vertex, so it's probably distributing the vertex group along these two bones of the FK chain. So if we uncheck this and select the vertices, so we're going to select that vertice, let's actually switch to face, so I can select the face, it's going to be faster, and then Control L. Then from there, if you go to the vertex group, we're going to look for the right front arm, so RF. So I believe this is this one, making sure it's the front. Yeah, right front. So we're going to remove the forearm and we're going to make sure the arm has a value of 1. So there you go. This one is fixed. Now this happens. Sometimes we're moving too quick when we're rigging. Now the only thing missing for this is to set some proper custom bone shapes for these controls. And we have a proper IK-FK switch for each of the legs.